All right, welcome back from break. Hope you're doing well. Congruent triangles. We already know what congruent means. Triangles, we've been working with them for a while. We know lots about triangles. So, hope you got a pencil. Hope you're ready to follow along. Triangles with the same blank and blank. If you're going to be congruent, you better be the same. Triangles have sides and angles. So that, a little bit of misspelling there. There we go. Angie's looks a little ugly. Handwriting's horrible. Sorry. Triangles. They got sides, they got angles, and importantly, you better have they better be exactly the same, right? You better have sides that match and angles that match. You can't say that we just got the same sides or we just got the same angles. This means all corresponding parts. Now, same thing. Sides and angles. Yes, you can, but I only have a couple left, so you get one for the whole week. Either don't lose it or make sure I get it back. All right, going on to congruency statements. So, if you look here, when triangles are congruent, we can write congruency statements. Okay, that's where you write triangle ABC. Remember this symbol, it's coming back. That means congruent. It's an equal sign and the little squiggly bar on top of it. It always makes me think of toothpaste. I don't know why. Triangle ABC is congruent with triangle DEF. And if you look at that, look in all the angles, you can see that A and D are matching. B and E are matching. C and F are matching. You can also see that AB has one slash, which is matching up with DE, which has one slash. So when these are congruent, this triangle has parts that are congruent with this triangle, which is where we're going down here to the CTCPC. I don't know whose idea this was to make that into some kind of thing, but here we go. C is going to be congruent. Okay? So when it says CP, that is going to be congruent parts of congruent. What do you think the T stands for? Triangle. Yep, triangles. And what do you think the C stands for? C? Yeah. Congruent. Again, it's silly. I don't know, but at the same time, that's really the only new concept for today. If you got congruent triangles and they got congruent parts, then they're congruent. I mean, it's basically saying the same thing 3 times in a row, but if we know 2 triangles are congruent, then we know that every pair of corresponding parts is also congruent. Now, corresponding parts, this first word, corresponding, you can think of it either way, but corresponding parts is talking about, we can't say that every single piece of this fraction of these 2 triangles are the same, right? So we don't have a single curve in all the corners, right? We don't know that these are equilateral triangles. We just know that ABC is congruent to DEF. Let's see how that looks. Okay. So it says list all congruent angles and sides given the congruency statement. We know that angle JKL, or triangle JKL, is congruent with triangle PQR. And so what we're going to say is we're going to say angle J is congruent And which one is J congruent to? Now, if we look back here, they said A first and D first. Are A and D matching? Yes. Then they said B, and then they said E. Are B and E matching? Then they said C, then they said F. So when you're naming a triangle, you got 3 letters. You can do them in any order, right? We could say ABC, we could say CAB, we could say BCA. But when you're talking about congruent statements, we're learning that you got to line them up, all right? If you say ABC is congruent with DEF, that tells you that A and D are the 2 congruent angles. That B and E, basically first congruent with first, middle congruent with middle, last congruent with last. So down here, we don't just get to pick random ones, right, and just say, oh, you know, J and Q. We say the first is congruent with the first, which is P. So which one is K congruent with? Angle K congruent to angle Q. Angle L is congruent with, wow, flying by today, congruent with angle R. Now the sides are always, they always trick people up a little bit more because it's not 100% as obvious. Goodness gracious, I got trauma. No. So when it comes to the sides, remember that sides need to have 2 letters to call them, okay? You can't just say side J because J is an angle and you can't just say a side J. So we got to give 2 letters here, okay? So if we give the letters J, K, JK is congruent to P, Q. So you just kind of, you know, we did the first 2. Which one you want to do next? We did JK. I'm sorry, whatever I said. Next up, let's do KL, right? KL should be congruent. That's second and third. Should be congruent to QR. Second and third. The last one, you know, we can do first and last, which is JL, should be congruent to first and last, which is P and R. So it says write another valid congruency statement, okay? And the first time you do it, you're probably thinking, I'm not really sure. Basically what we've just did is we've matched everything up, right? J matches with P, K matches with Q, L matches with R. And this is, if we write it in the order JKL, we have to write it in the order PQR. But let's say that we started this off and we did it different and we said KLJ. All right? This is still fine. You're allowed to call JKL, you're allowed to call it JK or KLJ. But when you do that, you're going to have to switch the order of the other triangle. So when we switch this around and we did this in order of second, third, first, what would our other triangle have to be called now? QRP. Because we did the second, third, first. So over here, second, third, first. All right. Do you feel like we need to do the whole thing a second time? I don't think so. I'm bored with this. Let's move on. Now down here, here's where we really get to do it. Right here, here's where it's a little bit more reasonable because we got pictures here. We're given that KPM is congruent with AYC. Complete each of the following statements. Now, here's what we're going to do to start off. And this is, I'm telling you, students who are like, Mr. Collier, I don't get this. Mr. Collier, I'm struggling. It's because Probably you weren't really paying attention during the notes and you were watching the video or something, but it's also because you're not doing this step, okay? When we look at this triangle up here, it becomes very clear that A and D are matches because they have 1 and 1. And it becomes clear that BC, which has 2 slashes, is a match with FE, which has 2 slashes. So whenever we're doing these and they're telling us that we have some congruencies, let's take advantage of that and let's label these so that they become easy to figure out. All right, I see that we have K and A as our first two. So in A, I'm going to put a single little curve, and in A, I'm going to put a single little curve. And then we're going to do the same thing, right? P, I'll give it 2, and Y, I'll give it 2. And then, of course, M and C, we'll give it 1, 2, 3, 1, 2, 3. Now it is very clear when I look at these triangles which ones are matching up. All right? I can do the same with the sides. The sides, there's a couple different ways to do it. All right? You could say KP, I'll give 1 slash. That's the first 2. So then AY, that's the first 2. I'll give 1, 2 as well. Okay? Some people get in the habit of saying, well, in between the triple and the double, in between there, I'll give it 2 slashes. So in between the triple and the double, I'll give it 2 slashes. Right? There's a couple different ways to think about it. And for this triangle, it's pretty obvious. The long side, we'll give it 3, and the long side, we'll give it 3. Now that makes it easy because this is an obtuse triangle, but for an acute triangle, it's much more difficult to do that. All right, here we go. KM. Let's find KM. I see that K and M are making the long side of this triangle. So what is that congruent to? CA. Sweet. Done. Not too bad. And these little slashes help us out so much. CY is a side. I see CY. That's my double slash. What's my other double slash? PM. Sweet. Done. Not too bad. PK. That's my single slash. What's the other one? YA. Sweet. Not bad, not bad. Angle Y is my double, I'm not even sure what to call this thing. Double little circle thing. Double curve. Y is my double curve, so P is my other double curve. Which one matches up with K? A matches up with K, angle A. Now this one's a little weird. It says angle ACY. Remember, you can name an angle with 3 letters. The middle one has to be ACY. So here we're talking specifically about the triple bump here on the C portion. So we're talking an ACY. You can basically think about it just like with the triangles. You got to keep them in the same order for everything. We're going to go with angle. And one way to think about this is, you know, A is the single. So we can start with K. And then C is the triple. So that would be M. And then, of course, P is the only one left, so we're going to finish with P. Triangles, very similar. Just find your matches and go with it. Anybody got the triangle for letter G? You said CYA? CYA. I heard somebody else confirmed it. M matches with C. Y matches with P, and A matches with K. Sounds great. Then we have YAC. You said PKM? PKM. Y is the double, P is the W. Double. A is the single, K is the single, and M is the triple, C is the triple. Now, as much as this wasn't all that bad and we moved through it pretty quickly, if you don't label these triangles, this can be this can give you a headache very quickly. Imagine if every time you went to do one of these questions, you had to go back to these three letters here, and you had to think in your head, okay, well, the first two, and then just label your triangles, and it will help you out so much. Flip it over the back. We're making some great progress. We've only got a couple questions on the back here. Same thing. We find out right away that STW is going to be congruent with BFN. Let's just label this quickly and be done. B comes first and S comes first. Single, single. T's in the middle, F's in the middle. T gets a double, F gets a double. W comes last, N comes last. W comes last, N comes last. Well, that's 82. I kind of wrote on top of it. Then if you want to think about the sides, ST we'll call 1, BF we'll call 1. TW we can call 2, FN we'll call 2. And then of course there's only one side left, so we'll give that the triple, and we'll give that the triple. Now that we've got all this organized, it is going to be so easy from here to figure out the rest of these things. So, figuring out the rest of these, it says BN. BN is our triple. Now, BN is going to be the same as WS, which is equal to, now we've introduced, pardon me, now we've introduced actual numbers. And since WS has an actual length, and it's the same as BN, then 9 is also the length of BN. If these triangles are the same, and BN is the same as WS, then they're both 9. TW. TW is our double, which is the same as FN. We know that FN is 14, so we know that WT has to also be 14. And I guess these are centimeters, so we'll be teachers' pets and put centimeters on there, you know what I mean? I feel like they're trying to get me in trouble with this FN and BF, but whatever. So BF is 1, TS is also 1, and TS, they've given us a value, is 17. So we can figure that out. W is the triple, N is the triple, and what is the actual measurement for N? 82. B is the single, S is the single, the actual one is 67. Sorry. F is the double, T is the double, but I don't get the actual measurement of F or the actual measurement of T. So this is where we're building our triangle knowledge. If you know 2 of the angles, you should always be able to find that third angle, right? I know we just had break. All of the angles of a triangle add up to make 180, right? So we should have 82 plus 67 plus X. I can't use capital. All of those are equal to 180. We can set it up this way, and we can go looking for it, but really we should hopefully, be making our way to 180, take away 82, take away 67, and what's left? 31. You see, we're getting the same answer both ways. 31. I can't emphasize enough how nice it is to put these. I know you might be thinking, oh, I like to take as many shortcuts as I can. It is a shortcut to write all of these things, I promise. All right, we are going to switch up a little bit with number 5. if you're feeling like, Mr. Collier, I got this, this is so easy, I'm bored, there is something new going on here with number 5, okay? Number 5, check this out. From the very start, we have been given, before we even went anywhere, we were given these 2 slashes, okay? That means that these 2 sides are equal to each other. Instead of making a triangle with all 3 different angles, all 3 different sides, we are now going to be making a triangle where we have 2 sides that are equal to each other. That's going to have a couple different kind of differences that it's going to make, okay? When you have 2 sides that are equal to each other, you will also have 2 angles that are equal to each other, okay? Because whatever this angle is, angle G, it is opened enough to make this length, which is 27. Angle J is also going to be the same angle. It's something that we talked about. It's been a while because of break. It's been all the way back, like, almost 10 days now. But if you have corresponding congruent sides, you're also going to end up with those angles that match as well. Okay? So, right away from this question, we're starting off with a lot of similarities. Okay? Let's check this out. For question 5, G is the same as X. So let's put a single slash over on the X, or curve, I guess. H is the same as Y. So let's put double curves on H and double curves on Y. Yeah. But then when it comes to the J and the Z, we already talked about this. The J does not get a triple curve. The J is going to stay as a single curve because the J matches with the G. If these are the same sides, then these have to be the same angles. That means the Z is also going to get a single curve. Because these are congruent triangles, they should be the same exact thing. They're just kind of twisted, basically. And when we go to get our sides figured out, the first 2 letters is GH. GH is the left side. GH, we have 1 slash. That should be the same as XY. XY, I'll give it 1 slash. So when it comes to sides, we use 2 letters. So I looked at the first 2 letters here, which is GH. And this GH should be the same as the first 2 letters here, which is XY. So GH and XY should be the same. GH, XY, GH, XY. Then I'll do maybe the last 2 letters, okay? H and J. H and J should be the same as Y and Z. H, J already has a single slash on it, so we're going to stick with single slashes. HJ matches up with YZ. And again, at the same time, I don't know if I'm overcomplicating it. Look at the 2 triangles, right? They're the same. So, I know one's upside down, but they're the same. The last one is going to be the bottom. And so, if the last one's going to be the bottom, well then, we can put 2 here and 2 here. Okay, let's finish this up quickly, right? GJ, okay, here's GJ. It's the bottom. It's the double slash. The double slash is over here, which is ZX. And we have the actual measurement for ZX, which is 18 feet. XY, XY is on the side. It's one of these. Now, we should have 4 of these sides. They're all going to be the same thing, right? We've got 27. That one's going to be 27. And they're congruent triangles. So that one's going to be 27. So that one's going to be 27. We got lots of 27s. XY is the same as many different sides, particularly HG is where we got 27 feet from in the first place. And then same thing, ZY, it's one of our 27s, right? It's the same thing as many different, including HG. I don't know, my G's keep looking like my 6's here. I don't know what's going on. That was even worse. When it comes to angles here, angle H is the double. Well, that one's going to be 38.
Question.
What's up?
For ZY, what does that say?
I know, it's horrible. It just is, it says HG, which is 27. Right, because ZY is one of these side ones, and so I look at the side one there, HG. Now, these last two angles, we're actually going to have to think about this for a little bit. These last two angles, Z and J, okay? I have Y figured out. Y is 38, and that's the same as H, so I've got those figured out. Okay, the pink is solved, the pink is sorted, the pink's all good. However, if I look at G and J and Z and X, all four of those are all the same, but I don't have any of their measurements. I don't know what G is, I don't know what J is, I don't know what Z is, I don't know what X is. So we are kind of stuck for a second. Okay? What we do know is that G and J are equal to each other, right? G and J should be equal to each other. So here's what we're going to do. We're going to start off. How many angles are inside a triangle every time? 180, right? And how much do we know about? How much do we have accounted for? We know that this little double one here is worth 38 degrees. So we don't have 38 degrees. Take away 38. We have 142 left. All right? So we know that G and J are going to add up to make 142. But we also know that G and J should be the exact same. So you just cut it in half. 142 divided by 2. My face is in the way there. There you go. 71, right? You just subtract the one that you know and cut the rest of it in half. Good enough. So 71, and they're all going to be 71. Now, at this point, we pretty much get it. You can kind of notice that from here on out, the only way that they're making this stuff any harder is they're just adding in some algebra to it, right? We're adding in some x's. Notice that we have x, y, and z. The reason that you have x, y, and z is because these things are kind of unrelated. So that's why you have three different things. I do want to make one point, and I want you to kind of look up here. I may have, if there's a geometry purist out there, I may have made a little bit of a goof, okay? Maybe not a mistake, but something that wasn't perfect, okay? So, what a geometry kind of purist would say is that we know that across from angles, like if we look at B here, right? Across from angles are sides. And the best way to set this up, especially if we're doing, you know, a scalene triangle with all different sides, is to put the double slash side on the one that is opposite the double curve inside. So let's set that up when we do this one, okay? There's no mistakes, but it is just a little bit neater. Let's start with our angles. U, we'll say that's a single, and T, we'll say that's a single, right? And then let's just go straight across from the U And let's make that a single slash out there as well. Okay, so we just go straight across. If U is a single curve, then VW can be a single slash. And that makes it a really quick, really easy way to kind of do this. The middle one is V, so let's put a double curve on the V. The middle curve is the S, or the middle angle, I guess, so let's put a double curve on there. And then let's go straight across, and let's put the double slash and the double slash. And then the third one is a W. Let's do a triple, triple, triple. The R is last. 1, 2, 3. And then straight across from those, 1, 2, 3. 1, 2, 3. And that just makes everything a little bit tidier. The way we were doing it before, where we were just kind of randomly putting angles and sides on there with different combinations, it's okay, but this is just a little bit neater, a little bit better, and just kind of better organized altogether. So let's talk about what number 6 says. It says, given these two triangles, find the values of x, y, and z. Now, x, y, and z, these are variables. These are not side lengths, right? So we're not talking about 57 or 53 or 50. We're talking about give me the variable that works in there, okay? When we're talking about x, y, and z, if you look at the information that we have, all right, we know that this is a side, this is a side, this right here is a side, this is a side of a triangle, this is a side of a triangle, this is a side of a triangle. Every single number on the entire question has to do with sides of a triangle, right? So are we talking about angles here? Definitely not, okay? We know that all the angles add up to make 180, but we're not talking about angles. These all have to do with sides. So how are we going to set this up to solve these questions? It's really pretty straightforward, all right? You're going to look at this piece here, which is 12x minus 7, 12x minus 7. And if 12x minus 7 is on the triple slash, it should be equal to whatever else is on the triple slash. What number is that? 53. So you make a little equation like this, and you figured it out. That's the whole thing, right? Triple slashes should be equal to triple slashes. So we got it. We're good. We're figured out. Okay? And we can just go straight to Desmos, take advantage of this ridiculous supercomputer that solves all of our problems and does our taxes for us. And, you know, we got it from here. Type it in, figure out where the line is. What is x going to be equal to? 5. Easy. Awesome. X is equal to 5. Fantastic. Somebody help me out with the equation for y. All right? So find your equation that has a y in it. I see it right here. Right? This one has a y. It says 5y minus 33. And what should that be equal to? I see that this has a single mark or hash or slash, and so I'm going to go to this one, 57, which has this single mark, and just put an equal sign, and we're good to go. If they are a congruent triangle, these sides should be congruent. So we're good. We got it. Go to Desmos. 5y minus 33 equals 57. That's a y, that's why it's a horizontal line, and there we go, 18. Y equals 18. Who can give me the last equation? I'm not telling you anything. What do you got? You said 12 is the answer? Okay, what's the equation that leads you to 12? I got you. So, I mean, like, I'm looking for even simpler than that. You're already solving the equation. I'm talking for just set me up with the 3z plus 14, right? That's this part that we're still looking for, and that's equal to 50. That's this part. The double is equal to the double, and then, yeah, as far as solving it, you're right. Subtract the 14 divided by 3. If I try to type this in Desmos, 3z plus 14 equals 50. Desmos is struggling a little bit. Desmos has this error sign, this triangle, and Desmos says we only support x's and y's. So just backspace the z, put an x in there, 12. So we should have z equals 12. You're right. All right, we're at the very end where notes have been going on long enough. One more question. We're going to skip 8. We're going to skip 9. You got to draw your own pictures. You might have to deal with that. All right. Now, let's look at what we got for this question. All right. 6x minus 29. Is that an angle or a side? Look at, you see how it says a degree symbol there? This is going to be an angle. 36, is that an angle or a side? 36 is an angle. So on the inside there, it's got a degree sign. This one is an angle. 115 is an angle. 4z minus 32 is an angle. Okay? So, we've got angles now. When we have these angles, we still have congruences. I still want to put some nice curves in there. P comes first, I'll give it a single. C comes first, I'll give it a single. H is next, I'll give it a double. N is next, I'll give it a double. And then S is last, that can have the triple. And F is last, that can have the triple. And I could do the same with the sides. Honestly, this question has nothing to do with sides, so it's not that important. But again, across from the single is a single. Across from the double is a double. Across from the triple is a triple. Across from the single, across from the double, across from the triple. Those side markings aren't that important. This question has nothing to do with sides, but it's still good practice. All right, if I try to set up some equations here, all right? If I try to set up some equations here, let's say I wanted to try to figure out, if I tried to go for the triple one first, right? If I wanted to go for the triple, the problem is that I don't know what that triple should be. So the triple's not a good setup to go for first. You want to go for the single or the double part first? Okay, if we go for the single one first, that's 36 equal to, and the single over here is 4z minus 32. All right, we can go to Desmos. We can do 36 equals 4z minus 32. We get an error message because we used a z, so I'll hit the backspace and put an x in there. 17, excellent. Z equals 17. All right, now let's do the double. The double is 6x minus 29. The double is 115. Somebody else do this one for me. Go to Desmos, type this in, give me an answer. What do you say? 24? 24 feels pretty good. Yeah, I like 24. Nice job. Now this last one, again, if I look at this triple, as far as the triple is concerned, I got question mark. I don't even know what that one is, and this one is 3y minus 1. How can we figure out the value of y? It always comes back to the same thing. All the angles in a triangle add up to make 180, right? It's almost like that's all you need to get through geometry at this point, right? Now, over here, I see 36. Over here, I see 115. Even though those are in different triangles, they're congruent. They're the same triangle, right? I know that my single is equal to 36. I know that my double is equal to 115. And so what is my triple gonna be worth? Go to Desmos. Start with 180. Take away 115. Take away 36. And I got 29. Is that what you got? 29. Nice job. So my last angle is going to be worth 29. And guess what? The question mark? It's a 29. All right, that means 5 minutes till lunch. Let's finish up here. 29 is equal to 3y minus 1, 10. So y is equal to 10. All right, we are not, very cool. We're not going to solve 8 or 9. I am just going to draw 2 triangles. Just to draw 2 triangles. Now the good news is, when you get to draw 2 triangles, just draw them the same, right? Make them look the same. They're being extra cute and turning these triangles around and flipping them upside down. When it comes to our triangles, we'll just make them look the same. Label them D on the left, and so the next is J on the left, E on the top, K on the top, F on the side, L on the side. And then give them 1, 1, 1, 1, 2, 2, 2, 2, and then 3, 3, 3, 3. Right? There's our nice triangles. Draw them up real quick, label them, put them things where they need to go. I will say, before you start a question, is what we did on 6 and 7. We decided, is this talking about sides or is this talking about angles? And make sure that you organize yourself in that way. When I look at 8, it's talking about DE, EF, DF, JL, JK. Those are all sides, right? I'm thinking for this one, we're dealing with sides. Nothing to do with 180, right? Because these are sides. So we're not going to set up a 180 equation here. When I look at 9, it says QR, QS, MP, but then it also says angle S, angle R, angle M. So I'm thinking, okay, I might have to do some sides, and I might also have to do some angles as kind of 2 separate pieces. I got sides and I got angles. Okay, before you start, I would just recommend you think about that. At the end of the day, you're just looking for matches, right? It ain't that bad. You're just looking for matches. Don't forget, all the sides make 180. I mean, that's triangles. All right.